All right, so in this video tutorial, we are going to be learning the second and final method for evaluating deductive arguments for their validity. Okay, so previously we learned about truth tables as a method for showing whether a deductive argument is either valid or invalid. Okay, and that's really a strength of truth tables, is that they show us when an argument is valid or invalid. Okay, now a downside of using truth tables is if we have too many different distinct letter variables, the truth table can get quite large, right? So when we were working through the truth tables, we saw that if there are three distinct letter variables, there's going to be 8 rows for the truth table. Okay, and if we had a fourth, it would be 16 rows, fifth, 32 row, sixth, 64 row truth table. That is impractical for testing for validity. Okay, so there is this alternate method, natural deduction, and it is really efficient and useful for deductive arguments that have more than 3 letter variables. Okay, and I take it that is the main strength. The second strength is it shows validity 100% of the time. Okay, now a downside of natural deduction is it does not prove invalidity. Okay, that's what truth table does do. Okay, natural deduction, however, it only demonstrates validity by using a series of valid inferences. Okay, so for the arguments we're going to be testing using natural deduction proofs, they are all valid. That's an important thing to keep in mind as you go through the exercises. Okay, none of these arguments will be invalid. If a deductive argument was invalid and you were attempting to use a natural deduction proof for it, the proof would just go on infinitely. You would never be able to prove the conclusion, okay, because the argument's invalid, right? So because I'm a benevolent person, I'm giving you only valid arguments, okay? Now, that's not enough, right, for the testing of the arguments, right? You can't just write valid because you know it's valid. What you have to do rather is you have to complete the proof showing why it's valid. All right. Now, in order to complete a natural deduction proof, you need to be able to utilize certain patterns of reasoning. Okay, these are our valid inferences, or the first 4 valid argument forms that we've learned about previously. Okay, so modus ponens, modus tollens, disjunctive syllogism, and hypothetical syllogism. Okay, now what we're doing in a natural deduction proof is we are working with a set of premises. Okay, the premises in the deduction proof are the numbered lines, and what we want to do is we want to find the conclusion here. Okay, this is the conclusion, not C. Okay, so through a series of valid inferences in the proof, okay, we will demonstrate why the argument is valid. Okay, now, thinking about it a bit more abstractly, we know already from the truth tables why each of these 4 argument forms are valid 100% of the time. Right? I could take the modus ponens argument form here, for example, put it through a truth table, and we would discover there are no rows of true, true, false. Okay, and that holds for the other 3 as well. So it's in this way that we're safe using them as valid inferences to apply in the proof to discover our conclusion here. Okay, now what we need to do to get the proof up and running is start adding premises. Okay, and we're going to have additional premises by applying these patterns here, these valid inferences, okay, in our proof. Okay, so what we need to start with is we need to look at the premises, okay, 1 through 3 here, and see if there's an inference we can make by applying one of the argument forms here, one of the valid inferences. Okay, so it's going to be important that you begin just to recognize these patterns of reasoning just by looking at them. Okay, in their sort of generic form here, and see if you can discover that to render a new premise here as an inference. Okay, now looking at our first 3 premises here, okay, I noticed that the third premise is the antecedent in the conditional in the first premise. Okay, so the first premise reads, if A, then not B. I see that 3 is the affirmation of the antecedent here. Okay, now looking at the modus ponens, something similar is going on here. Okay, and we know that whenever we affirm the antecedent, the consequent always follows in a modus ponens. Okay, so if A, then not B, A is the case, as stated in the third premise. So we can thereby infer as a conclusion, right, from the pattern here, not B, the consequent. Okay, so that's going to be a new additional premise in the proof, right, from 1 and 3 modus ponens inference. Okay, it's very important in the proof that you show how you deduced the new premise. Okay, so this is what we call the justification. It justifies how we got this. Okay, I did it by applying 1 and 3, and I got 4, right, as a new premise through the modus ponens inference. Okay, now any of the additional premises in the proof become available to us for further inferences, right, with the idea of getting here to not C. Okay, now I don't see negation C anywhere in the premises. So I know that I'm going to have to apply another argument form. I'm going to have to make another inference and see if I can get there. Okay, now I recognize that C is the antecedent in the conditional claim in premise 2 here, right? And looking at the 4 valid inferences here, I recognize that in the modus tollens argument form here, if I can negate the consequent in the conditional here as the first premise, I thereby deny the antecedent. I can negate the antecedent as well. All right, now here C is not negated as the antecedent. The conclusion it is. So that's what we need. Well, look at 4 here. Okay, 4 as a new premise, not B. Oh, okay. Well, if C then B, here we can negate or deny the consequent in 2. And whenever we deny the consequent, according to the modus tollens, we have to deny the antecedent as well. Okay, so I get that from 2 and 4 via a modus tollens inference. Okay, now at this point we have deduced in our proof the conclusion. We have just demonstrated how the conclusion follows through a series of valid inferences, right, from the stated premises here, right? And once we deduce the conclusion, we're done. Okay, once we get the conclusion here, there are no further steps to take, and we have completed the proof. We have demonstrated validity. Okay, now a few things to keep in mind as you begin completing these on your own. First, there is no standard order for the proof. Okay, now that's just to say that you might start your proof with a different inference. In this argument, there really isn't any other inference to start with besides modus ponens from 1 and 3. But in some of the longer proofs, there will be different starting points in your proof, right? So that's just to say that your proof might look a little different than, say, a classmate's or mine, but that's nothing to be worried about. You haven't done anything wrong. Okay. Now, another thing to keep in mind is if you are, working through a proof, and let's say, you are really deep in the steps. Let's just imagine that you were at step 16, right? And you're just wondering, how can this be a valid argument? It just keeps going on and on and on. If you find yourself at this point in the proof where you're really deeper than 11 or 12 steps, you're going to want to go back and check your work. Okay, for all of the proofs that we're going to be completing, given that we're only using these 4 valid inferences, I don't believe that we're going to be going any further than, say, 12, maybe at most 13 steps. So if you find yourself in this spot, look back and make sure that you haven't misapplied in argument form or used the wrong lines. Okay. Now, in subsequent videos, we're going to look at a couple more of these deductive proofs, and they're going to be each slightly more complex than the previous. Okay, so all of the proofs are not going to be this easy, right? A two-step proof. Some will be longer, as we'll see. But this gets us up and running.